This is Stanford Engineering's The Future of Everything, and I'm your host, Russ Altman. If you enjoy The Future of Everything, please hit follow in whatever app you're listening to right now. It'll guarantee that you never miss the future of anything. Today, Rishee Jain will tell us that although we do design the buildings in which we live and work, they also affect our behavior. He and his colleagues are coming up with ways to dynamically change those environments so they adapt to our activities and our preferences. It's the future of the built environment. We have a new segment that we're introducing today at The Future of Everything called Future in a Minute. At the end of this segment, after I'm done talking to the guest about their work, I'm going to ask them a few questions and ask them for rapid fire responses that they will respond to, and we'll present it in our new segment, which, as I said, is called Future in a Minute. Before we get started, please remember to follow the podcast in whatever app you're listening to so you never miss the future of anything and you're alerted to every episode. So when you think about the built environment, you think about buildings, sidewalks, parks, gardens, infrastructure like the pipes that bring us water, take away waste, electricity, internet. But there's been changes in how we design environments. In the old days, we just built a building, put it up, waited for 30 years until it was out of commission, took it down, built another one. There's now a new generation of civil and environmental engineer that's thinking about how can we make these buildings more sustainable? How can we have them adapt to our new ways of working? A lot of us work at home. We go to work and we just borrow some space for a while. When you're in that space, how do you make sure the temperature is a good temperature? How do you make sure that the lighting is right for you? How do you make sure you engage in healthy behaviors at work? Get up, walk around. All those things are something that a clever architect and a smart engineer can design and build to make these buildings better and last longer. Well, Rishee Jain is a professor of civil and environmental engineering at Stanford University, and he's an expert at the interaction and intersection between buildings and social systems. He's going to tell us that you can expect buildings of the future to be much more responsive to your needs, much more flexible, and hopefully more comfortable. Rishee, what made you decide to focus on the built urban environment and ways to improve it as the focus of your professional research life?
Well, thanks, Russ, for having me on the show first and foremost. For me, it was really about being able to touch and feel what I work on every day. And so I remember, for me, I used to help my dad around the house, a bunch of things, doing home projects and building things. And that's what got me interested in understanding how we shape our built environment in buildings. And then as I sort of progressed in my educational career, I realized that this is something that I can design, build, engineer, and then actually get to touch and actually see the end product. And I think that's hard to do in some modern technologies when they're especially gone more digital. Of course, I do a lot of stuff in the digital domain, but eventually, hopefully, it gets built and we get to touch and feel it.
That's great. And so on your web pages and in your writings, you talk about this is not just about technical engineering stuff. There's also a social aspect. And people might be very surprised that somebody who's thinking about how to build buildings is thinking about the social side of that. So what is the social side of the urban built environment?
So I think that's a great point. I think traditionally engineers have thought as our buildings and our infrastructure is simply there's a bunch of people here, they need water, they need energy, let's build a pipe, let's build some electrical cables, they need a place to live, let's build some buildings. That was how we did things 25, 30 years ago. And I think what has shifted now is a more nuanced understanding of how people use spaces. What do they actually need? And how we can respond as infrastructure? So I like to give this example of, traditionally it was just, there was some demand. People needed some infrastructure. We built it, we scoped the size and we built it and that was it. Now we're sort of in this new, I would say, era of infrastructure where we can dynamically match supply and demand. And I'll give you an example of that. How we use energy or electricity can change dramatically, in the day. I'm not a morning riser. My wife is, so her coffee gets made 2 hours before mine. Mine comes a little bit later. My 5-year-old's running around in between and using various things. And so the way we live our life and the social dimension of our interactions frame and are embedded in our engineering decisions. Another quick example is, I think the COVID pandemic and the work from home really taught us to value our in-person interactions. So a lot of work we've been doing is understanding how people move in building spaces, how we can design collaborative environments that are also sustainable. So, you're not double heating and cooling if people are working from home, and also cooling office spaces, and how you understand and maximize that potential. So that's really what informs and was really drove me to embed this social dimension in how we design and build buildings.
You've also talked about and written how, although we design, you and your colleagues design buildings using these kinds of considerations, once the building exists, it also shapes the behavior of the people who are using the building. And I want to ask you about that, because of course that's true, right? It makes sense that the building I'm in is going to put constraints on what I can do during my day. But I have a feeling that we haven't thought, I think you have, but many of the rest of us haven't thought about the ways that the design decisions of the buildings we are living and working in are actually changing things like our health and our attitudes towards the world.
Absolutely, absolutely. And so I think this is also a sort of a new shift in the way engineers are approaching things. Before, we simply thought we shape our infrastructure, is how I like to put it. Now I think there's an understanding that our infrastructure shapes us too. And the reason that's important is, there's been lots of studies done by some of my colleagues that trying to understand your exposure to nature. What is the value of having that window and seeing a tree outside, in terms of as you go throughout your day? And it's been demonstrated to have huge impacts on productivity, well-being metrics, overall satisfaction and happiness. These are the type of things that are changing. A common example that's sort of given, in the literature is if you don't have sidewalks, people won't walk. If you don't feel safe to walk down the street and you're, worried about that, you won't walk. This is also the case of bike lanes and these sort of things. And so we have to start thinking about, when we design our infrastructure, that we're not just designing for the next 3 to 5 years, but how do we build in some flexibility? What does the future look like? How do we think about how future inhabitants can help shape the infrastructure, because it will inevitably shape them? And so I think that's been a shift. Previously, we said we're going to build something, it's going to stand for 30 years, then we're going to tear it down and build something new. I think that sort of mode of thinking has evolved.
So that this is great, and so one more kind of just preliminary, almost like a definition, is when I look at your papers that you've written and the talks you've given, you sometimes use the phrase urban form. It appears in a lot of the titles of your papers. What do you mean by urban form? And this, I think, a related question is, what is the unit that you think about? Do you think about a single building, or do you think about a neighborhood or an entire city? As you're doing your work, I think it would be helpful to understand what the scope is that you're considering. Because, for example, you just mentioned, pedestrian sidewalks and bike lanes. That's outside of a building. So that makes me
Yes.
guess that you're thinking beyond the building. So talk to
Yeah.
me about that.
That's a great question, Russ. So urban form, what we mean by that is, you know, the type and where buildings are laid out in the city. In addition to that, where you put green spaces, where you put roads, you could think of this as the layout. If you were the SimCity designer and you were plopping things in your little virtual world, that's what we're talking about, the urban form. And so my work actually sort of spans all these dimensions. We tend to think of things where we call intra-building dynamics. What happens within a building? How people are moving, how they're consuming energy. Then zoom up a little bit of what happens in the neighborhood, and then finally, zooming all the way back out. What happens in a big city across a city like San Francisco or the Bay Area as a whole? And I think what's interesting is making the connections between these scales. That's where a lot of the innovation has happened, because as what you are doing within your building, as you zoom up to your neighborhood, has an impact, and as you zoom up to your city, has an impact, especially as you aggregate these choices and this behavior. So, yeah.
So that's great, and but it raises a kind of maybe a logistical question. Is that means you have to get a lot of people on board for this activity, right? If you are looking at a single building project, there's somebody owns the land, they want to build a building, boom, okay, we have all the deciders in the room. If you're looking at a neighborhood or two owners or five owners or 20 owners, so
Absolutely.
is the world set up to implement your vision given these kind of real world constraints?
So I think that is a huge challenge, and I think what we often do is the decision maker and stakeholders are different at each scale. So if I'm thinking at the urban scale,
Yeah.
it's often policymakers, people who are making land use decisions, what and where you can build this, how high you can build this. So they're dictating those rules. They're not dictating down to the design of a window, but inevitably that big design decision floats down to the neighborhood where people are making decisions about where you're going to place parks. If you're going to allow a bike lane to be in a certain neighborhood or in a certain throughway, are you going to enable parking? These sort of things are in the neighborhood. And then finally, at the building scale, where you have the owner and operator of the building, they're accounting for those and making decisions based on that on how they design it. The architect's going to design based on sort of what those are. The engineer is going to design based on that. So they kind of fit together. While the stakeholders are different, they are inherently sort of linked at the hip, if I could say so. And so you have to take into
Yep.
account these
Yep.
different levers that sort of occur at each different scale. It also makes it difficult because, as you can imagine, changing policy is very different than convincing one building owner. But we tend to see innovations happen both top down and bottom up. If the bottom up approach is you see a new building being built or something being adopted, and folks say, well, we want that amenity too, or that's huge and that's helpful. You see a new neighborhood park in your friend's neighborhood, you may say, hey, why don't we have bike lanes in a park like that? And then when it gets to the city scale, it eventually floats up. Then you haven't moved the opposite direction. We have a directive or a change in policy. A big debate right now is the reforms to CEQA, which for folks that don't know, is the big environmental bill that helps, or I would say, dictates where and how you can build and the environmental review that's necessary for building housing in California. So changes in that are a big top-down approach in which that would shift,
Yeah.
all the way down
Yeah.
to the system.
Great. Okay, so we've set it up. We know what we're talking about. I'm very excited. One of the things that you work on is you talk about and work on dynamic infrastructure, and you've already said that in the olden days, it was kind of static. It's like, let's make a plan, let's build it. Hopefully, we'll get 30 years out of it, and then we get a chance to redo it. But you have a very different model, and I wonder if you can flesh out what it means to have a dynamic infrastructure, because it kind of makes my brain explode. Because I guess I'm an old guy and I'm just thinking about buildings and sidewalks. It's like, what can be dynamic? But I think you have thought about ways to make this dynamic.
Yeah, so I'll give you an example. At the building scale, and then maybe at the urban scale. So at the building scale, as we've seen this shift from return to after the pandemic of everybody working from home to more hybrid work, we've actually been able to explore and understand how different spaces can be utilized in different ways. Often you had offices, conference room. Those were sort of very stagnant places where people either work by themselves or work together. Now we have this, dynamic dimension of hotspotting. People will come in and sign into a desk. Then they often will, camp out in a certain co-working space or have meetings in the conference room. What we can see now is that we can understand where people are using these spaces and then dynamically shift things around. This allows us to shut down heating and
Huh.
cooling in certain parts of the building that are no longer being used, when before we would heat and cool the entire building. So that's kind of what we mean by dynamic, is responding. Yeah. Um, and then I would
So
say, yeah.
what are the other levers? Yeah, please.
Oh, sorry. Go ahead, Russ. I think you had a follow up question.
I was going to say, what are the other levers? So I love the example of the thermostat, because anybody who's been in an office likely has either been part of or witnessed thermostat wars between the
Yes.
people who are running warm and the people who are running. And if you can solve that, thank you. Are there what are the other levers that you can kind of turn to modify an environment on the fly?
Yeah, so I think the two big levers that people interact with are thermal, which is, as you said, the thermostat, the comfort, and then the other thing is lighting. And so things that
Uh,
have been really, clever and cool and dynamic is you can have dynamic shading. So you can turn a space that was previously really hard to work on a computer with because of glare into a work-friendly environment by dropping shades or tinting the windows dynamically to encourage people to shift to that space. You can also turn on different types of lighting. We now understand that different types of lighting encourage different types of work. Lighting that mimics the sun is really great for concentrated work. Lighting that mimics sort of, more or less daylight and is lower on the Kelvin scale is more for casual work and these sort of things, maybe mingling. So these are the sort of levers we're starting to think about at the building scale.
huh.
But let me take you to the other side, where the time and spatial, dimensions change. So a big sort of thing that's been happening. I live in San Francisco, and so I've been experiencing this. But I can give you an example: is the city has turned to turning many of the city streets into night markets, in which they shut it down to vehicular traffic once a month, and there's various different themes in which now these become pedestrian-friendly plazas in which people can now use them in a very
Yes.
different fashion. And you see this with farmers markets and various different things. That is a way that the infrastructure is responding. It's often hard to rip up streets, but as soon as you shut down traffic, now this becomes a very different place for gathering than it was previously when you were constrained to the sidewalks. So these are the type of things we're thinking about. When you do these things, there's also downstream effects, right? The impact it can have on traffic, how people are consuming energy, all these things are that. So we have to take those into account, and that's what makes it fun to model, at least.
Yeah, that's really exciting, and I love that example because I think many of us have found the COVID, the restaurants, the spilling onto the street, the farmers
Mm-hmm.
markets. These have all been, like, at least in my neighborhood, huge improvements to the quality of life. And
Absolutely.
but I can imagine that you might want to have a system that is being smart about the lights, the traffic lights, and the stop signs in the area dynamically because traffic patterns will change and availability of streets will change. So those examples are great. This is Russ Altman. We're talking on the future of everything to Rishee Jain, and we'll be back in a minute. Welcome back to the Future of Everything. I'm Russ Altman, and I'm speaking with Rishee Jain from Stanford University. In the first segment, Rishi told us about the built environment, the buildings, sidewalks, parks, neighborhoods, and cities in which many of us live. How do we design those to be maximally flexible as our work habits, our play habits, and the climate are all changing? In this segment, we're going to focus specifically on heat and climate change. There are increasing temperatures in many parts of the world, and that has real implications for how Rishi and his colleagues build buildings. He'll tell us about an exciting project in Indonesia and also some of the things that we can do to help make our own homes and workplaces a little bit more comfortable and resilient. Also, at the end of this interview, we're going to introduce a new segment. We're calling it The Future in a Minute. I'm going to ask Rishi a few questions. He's going to give me some rapid fire answers, and that'll tie a bow around this episode. Rishi, I wanted to ask you about climate change because I'm imagining, and I know that this is affecting how you think about the built environment and how you're actually building buildings. And this becomes a more of an international, global concern. So tell me about extreme heat and how it's changing your life and that of your colleagues.
Yeah, absolutely. Absolutely, Russ. I think extreme heat is the biggest challenge facing building designers and engineers in the next several decades. I think, the challenge sort of takes two forms. One in which we have a bunch of buildings that we built many years ago that aren't ready for, this type of heat, weren't designed for it. So they need to be adapted to tackle
Yeah,
that. And
yeah.
then the other side of this is that there's a whole population in the world that is the most vulnerable. And these are often folks who are unhoused or live in informal settlements. It's an unfortunate reality, but 1 in 8 people in the world live in informal settlements. So that's nearly 1 billion plus people. Um, and they're often the most vulnerable to this type of extreme heat. Many of their housing is temporary in nature or informal in nature, as one would imagine. And when temperatures rise, they often are, taking on the brunt of this issue.
Yes.
And so this is some of the work that I'm really excited about undertaking right now with some colleagues at the School of Medicine. One of my colleagues, John Openshaw, who is an infectious disease doctor, and I are working together with a bunch of other team members to really understand how we can help change this. And the reason why this is important is because as extreme heat rises and heat gets very hot, it has huge impacts on human health. Things like how well we sleep, our vulnerabilities to sickness, how children's brains are affected, things like, maternal care, all sorts of challenges, kind of emerge. So that talks a lot about the problem. But I think as an engineer, I'm always trained to think about, what is a solution we can do?
Yeah.
So a solution that has been sort of proposed is what we like to call cool roofs, which is simply taking highly white and reflective paint and painting the roofs of many of these informal settlements. As engineers, we've done a lot of models, we've even done a lot of field studies to understand, okay, when we do this, it does change the temperature. We can get, changes in temperature up to 5 degrees Celsius. That can really matter.
Oh, that's a big deal.
Yeah,
that's
it's a big deal. Especially when we're at the higher ends of these things, when we're, measuring things like 45 or 50 degrees C. That's really hot. And every degree matters in that space, especially when we're talking about comfort, but also the other things. So we've been able to do that. My colleagues on the health side of things and have been able to tie heat and its impacts to human health outcomes. What we've not been able to do is actually tie these two things together. What happens when we make this change, and how does it impact downstream effects of human health? And so what we're doing together now is really taking those engineered systems and those human systems and putting them together and studying, if we do these type of things, if we paint roofs like this, what are the impacts downstream that they're gonna have on human health outcomes? We're doing this in Makassar, Indonesia, which is a large city and they have a pretty large informal settlement population. And many folks are interested in this. This is going to have a huge impact on people's health. But in addition to that, policymakers are interested because there's a huge challenge of when the heat rises, there's people that can't show up to work because they're sick. There's people that can't go to school. Elderly are impacted. So there's huge policy and health policy implications.
So this is really, so tell me, for your medical and health colleagues, what kind of study do you do? Because I can imagine some of these are short-term benefits, but there's going to be other chronic benefits that you would have to, it would take years to see the benefits. So how are you approaching that so you can kind of get, my guess is you're looking for some quick wins before you start doing 10, 15-year studies.
Yes. So there's, I think the holy grail for my colleagues, and I don't want to speak too much for them, is these longitudinal studies that actually demonstrate what are the real impacts on human health. Those are expensive and hard to do. What we're actually trying to do in this first project is actually just understand the impact it has on things like your heart rate, things on your sleep quality. So now with wearables being so readily available, we can actually hand out wearables to people, paint their roofs, and then measure these impacts in real time, which we know from prior work that does have an impact on those longitudinal dimensions. And so if we can just demonstrate some of these smaller key metrics, then we can say, hey, people are sleeping better, their heart rates are lower and not elevated. We hypothesize that's going to result in much better outcomes when we look 10 years from now, especially when we look at children and elderly, which are the two most vulnerable to extreme heat.
So listen, have you gone far enough into it? In addition to these quantitative measures, are the people whose houses are now white and reflective, are they reporting just informally any kind of experiences that give you optimism about the results of these studies?
So we're just starting that process of painting their roofs, but the reports in the past have been the case, and that they often report positive outcomes, largely because when we go in there and we paint it, we also repair if there's a hole in the roof or something like that. So these are often done in tandem. Because, I think about my own home. If someone says, "Hey, I'm going to come and, change your light bulbs," I'm like, well, that fixture is actually cracked. Maybe we should fix that first, right? So it's human nature to do that. So we often have to tag team these things together. And that actually demonstrates a material benefit to folks even before the hot season arrives and before they're really dealing with it. That are like, okay, we've repaired a few of these things as we're painting. So we've seen that effect happen. We have seen some reports of people's perception just being better of their living space. And again, it's hard to quantify these things, without a longer term data. But it's interesting. Anytime you make an intervention, I think my colleagues in the medical school call this the placebo effect. That people are just generally saying, we see someone caring about this challenge, and so it's reflecting on their well-being to actually, to have something done about it.
So to finish up, I want to go back to something that you just said quickly, but you said that there's a lot of buildings that need to be retrofit. And that's another way to handle this. So in the example that you were just discussing, you have the ability to actually go ahead and do some new white paint, and it might change things a lot. It reminded me of, I had a new roof put in, and the contractor told me that I really should have these silver linings on the planks, the 4x8s, and I noticed it. So I spend a lot of time on an elliptical trainer in my garage, and it could get very, very hot in the summer. But after these silver coated, and this silver was actually on the inside, but I think the idea is to radiate heat.
That's a cool roof, by the way.
Is that a cool roof?
Yeah, that is. It just looks a little bit different. So that has a different reflective property, and it sits underneath your shingles. But that's exactly what we're talking about.
So it did change my life, because my garage is much more pleasant to be in, and it kind of looks cool, no pun intended, because I have almost like this shiny mirror on the. So I wanted to ask, what is the status of our ability? In places like where you and I live, to do these retrofits, and what are the challenges, and kind of, is there anything exciting happening in that area? I was excited by my silver coated roof, but
yes. And so I think, this presents a completely different challenge, Russ. So I think when we're talking about other parts of the world, Asia, sub-Saharan Africa, they're building new cities, and they're building tons. I think the challenge for, here in the United States and many other parts of the world is, how do you retrofit old buildings? And I think the challenge on this is that it brings me back to this human component. Anytime you're going to design an intervention where people are living, you have to minimize disruption. And I think that that's the really big challenge and innovation that's happening in this space. So for example, you happen to be getting a new roof, and that was a good intervention plan. But had somebody not told you about that, and you installed your roof, you weren't going to go and rip up all the shingles and do it again.
And he really did need to tell me. I said, "What are you talking about?" Like, he told me about this, and I said, "What?" And then, of course, it worked.
Yeah, exactly. And so I think there's two things. One is that there's actually an information gap and training gap on how we get contractors and people who are on the ground building these things about new technologies, and how they may have a small cost differential of 10%, but often the payback period is a year or two. And you really get huge benefits from this. The second piece is how we design interventions that can be modular in fashion. How we can actually do them where they can be installed in your house in a day. You don't have to move out. You don't lose, you don't put giant holes in your wall where your kids sticking their hand in. Sorry, I've seen that from examples. Yes. Live those, and these sort of things. And so I think that that's where there's a lot of innovation happening. Everything from things that, often people don't think about, that goes behind the walls, and, 110 volt heat pump water heaters that could be plug and play, different types of new heat pump air conditioning and cooling and heating systems that can be easily placed and put in place in lieu of what you have in now, without a ton of ripping up walls and these sort of things. And so that's a lot of where I see the innovation happening, is how you design products and new things that can be plug and play, rather than having to be a complete gut renovation and redesign.
So that sounds great. And that sounds like it could be a tip for people who are wondering what they can do in their own situation, is that it might be worth a consultation with a structural engineer or a contractor to find out which of these kind of, I don't want to call them quick fixes, but these more modular solutions might be a winner winner for them.
Yeah, and there's actually a lot of innovation in software that allow you to put your address in, and they can do some very cool analytics and using new generative AI
Yep.
tools to tell you here's some potential places you should look, given the age of your building, where you're living, these sort of characteristics. And we work on some of those models too, because I think people just don't know. And so, if they can type their address in and say, hey, next time you're thinking about, or next time you're doing this type of, you're replacing your washer and dryer or doing something like this, here's a quick win you can do. And you can buy that appliance at Home Depot or wherever you buy anything else you buy.
That's great. And thanks. And thanks to Rishee Jain. This is Russ Altman, The Future of Everything. We're going to move to a new segment now. We're calling it Future in a Minute. And I'm going to ask Rishee a few questions. And I've asked him to prepare short, sweet answers so that we can understand the future of the urban environment in a minute or less. So, Rishee, thanks so much for being willing to do this. I guess I should ask, are you ready?
I am.
Okay. So first question. What is one thing that gives you the most hope about the future?
Our ability to adapt to challenges. We've done it in the past as humanity. I think we can do it in the future.
What is one thing you want people to walk away from this episode of The Future of Everything remembering or now knowing?
That we shape our infrastructure, but our infrastructure shapes us. So think about those decisions.
Aside from money, what is one thing that you, Rishee, need to succeed in your research?
I would say willingness of the public to try new tools. I think the challenge we have is we're developing all sorts of new things, but until we actually put it into play in the real world, we don't learn and we don't know what doesn't work.
If all goes well, what does the future look like?
The future to me looks like a place where everybody has safe, comfortable places to live and work, and their environment can adapt to who they are, not just the generic person.
And finally, if you were starting over again and you needed to get your PhD in a different discipline, what would that be?
I would say I would go back and get a PhD in art history or architectural history. I think there's a lot we can learn from how our ancestors did and designed and built and expressed themselves to inform what we can do in the future, especially when it comes to extreme heat.
That was Rishee Jain, and that was The Future in a Minute. Thanks so much, Rishee.
Thank you, Russ.
Thanks to Rishee Jain, that was the future of the built environment. Thank you for listening to The Future of Everything. Don't forget, we're approaching 300 back episodes where you can listen to a wide variety of discussions on everything. In addition, we'd like to ask you to tell your friends, neighbors, family, and colleagues about The Future of Everything if you're enjoying it. Word of mouth is a great way to spread news about the future of everything. You can connect with me on many social media platforms, including LinkedIn, Threads, Blue Sky, and Mastodon. You can also link with the Stanford School of Engineering at Stanford School of Engineering, or more briefly, at Stanford ENG.